Here, three of the basic trigonometric functions are given first. One is your sine function, another is your cosine function, another is your tangent function. So sine function, it is believed that the sine function is derived from the word sinus. Sinus means half chord. Half chord means ardha jya. It is told in Hindi or Sanskrit, that is ardha jya. Why it is named ardha jya? Because it was discovered by Aryabhatta, Indian mathematician. You can learn it from the NCERT book. It is already given in a box, that sinus, which is derived by the Aryabhatta, the great Indian mathematician. Then it was later transported to the Greeks and Babylonians or Egypt, and they later gave it name as sinus and sine. So after the sine, cosine was discovered by also the same person, it is believed. Cosine was discovered. After that, tangent function also discovered. The cosine is termed as the complementary of sine, and tangent is the ratio of the sine and cosine. It was later discovered. So before that, after knowing the history, we will come to what is that sine function, what is that cosine function, what is the tangent function. So here in the right triangle, sine function is given to only one ratio, that is opposite over the hypotenuse. Let us come to that. So this is the sine function. So sine function is defined as the ratio of the side opposite to the angle to the hypotenuse. So in the figure, the blue color stick side is called opposite, and the brown color is for hypotenuse. The ratio of the opposite to the hypotenuse gives you the sine function. So it is very easy to remember. Then comes your cosine function. So cosine function is also whatever the left part, that is the ratio of the adjacent side, or the side which is adjacent to the angle of consideration, that is called leg of the hypotenuse. Sorry, adjacent of the angle to the hypotenuse. So cosine of the angle is given as the adjacent over hypotenuse. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So it is termed as cos of theta, cosine of theta or cos theta equal to adjacent over hypotenuse. Then comes your tangent function. Tangent function is defined as the ratio of opposite leg to the adjacent leg, except hypotenuse. Whatever the other two sides are there, if it is opposite over adjacent, it will give you the tangent of theta or tan theta. Then comes your reciprocal functions. So three are the basic trigonometric functions, and other three are the reciprocal functions. Reciprocal means the opposite or the inverse of the previous three trigonometric functions. First one was sine of the function, so its inverse or reciprocal is known as cosecant of the angle. So cosecant of the angle is the reciprocal of the sine of the angle. It is the ratio of the hypotenuse to the opposite, because sine was the ratio of opposite over hypotenuse. Here cosecant will be hypotenuse over what? Opposite. So cosec A is equal to inverse of sine A, that is 1 by sine A, which is equal to hypotenuse by opposite or hypotenuse over opposite. Next part. Next comes your secant of the angle. The secant of the angle is the reciprocal of the cosine of the angle. So cosine of the angle was what? Na? Adjacent over the hypotenuse. So secant will be its inverse, that is hypotenuse over the adjacent, that is 1 by cos A, which is equal to hypotenuse over adjacent is equal to h by b. Then comes your cotangent. So tangent of angle was given by the opposite over the adjacent, but cotangent is its opposite, is its reciprocal, is its inverse, that is adjacent over the opposite. So cotangent of A is known as 1 by tan A, that is adjacent over opposite. So these are the 6 trigonometric ratios which you have to remember as per your choice, means as per your process you have to remember, but you have to remember these 6 trigonometric ratios to solve different types of problems. So here are some shortcuts it is given here to know or the remember the ratios. After this one, so in this figure I am observing there is a small right triangle ABC where one side is 8 cm and base, that is opposite, is 8 cm. If angle C is considered, opposite is 8 cm and adjacent is 6 cm. Another right triangle is formed here, that is there is a right triangle of opposite 12 cm and base 9 cm if F angle is considered. So here I will see what is the concept behind it. The right triangle may be increased proportionally, but the ratio of the trigonometric functions remains the same. Maybe the right triangle may increase proportionally, not increase in any other way, it should be increased proportionally, but the ratios of the trigonometric values remains the same. So in the first figure, let us consider in the first figure in triangle ABC, tan of the angle C is 8 by 6 as per the formula. It is opposite by adjacent, 8 by 6. So ratio will be what? 4:3. In the first figure it is 4:3. In the second figure, it is tan of angle F, as it is increased proportional from the first figure. So tan of angle F, that is 12 by 9. 12 is the opposite and 9 is the adjacent. So 12 by 9, this is also the ratio, it is 4:3. In the first triangle the ratio of the tan was 4 by 3 or 4:3. In the second triangle also it is 4:3. Similarly, all the trigonometric ratio values will be same. Ratio values will be same, not the values will be same, as the value of the sides are increased proportionally. As the triangles are similar, in the triangle chapter you have learnt, as the triangles are similar, as it is increasing proportionally, the trigonometric ratios will remain same. It will not change. I think you have understood. So there is a statement which is given as JF Howard. There is perhaps nothing which so occupies the middle position of mathematics as trigonometry. So trigonometry is the very important part. We have to remember all the things which can be used in daily life also. So here is the same thing written. ABC triangle is given, angle B is 90 degree, angle A is the angle of reference, that is theta, that is AB is adjacent and BC is opposite. If I will consider the angle C at that time, if angle A is the angle of reference, that is theta, BC is opposite, AB is adjacent. If angle C is considered, then AB will be opposite, BC will be adjacent. When angle C is considered, AB will be opposite and BC will be adjacent. The same things are written. Sin of A is equal to BC by AB, cos of A is equal to AB by AC, tan of A is equal to BC by AB. So these are some shortcuts to remember the T ratios: SOH, CAH, TOA. So these are the shortcuts. It's your choice to remember. In your own way, you can remember also. So written SOH means sine of opposite over, sine is opposite over hypotenuse. CAH means cosine is adjacent over hypotenuse. TOA means tangent is opposite over adjacent, which we have already learnt. So here are some questions which are given on the basis of the trigonometric ratios. So triangle ABC is given where AC is equal to 20 centimeter or 20 units, BC is 21 units. I have to find out sin B, cos B and tan B. So angle B is the angle of reference. With that, AC will be opposite, BC will be the adjacent and AB will be the hypotenuse. Taking them as opposite, adjacent and hypotenuse, you can find out these trigonometric ratios. Second thing, in the same figure, the upper figure, another question is given. Tan A is 3/4. Tan A is 3/4. We have to find out sin A and cos A. So tan A is 3/4 means its ratio is 3/4. So you have to take the lengths as 3x units and 4x units. As tan is given, it is opposite over adjacent. So opposite is 3x units and base or adjacent is 4x units. You just find out the hypotenuse, that will be 5x units using the Pythagoras theorem. After that, you can find out sine of A. Here in the previous question, angle B was considered as the angle of reference. Here angle A is considered as the angle of reference. So angle A is taken means BC will be the opposite, AC will be the adjacent and AB will be the hypotenuse. So it will be reversed as that of question number 1 as the angle is changing. So putting those, you can find out the different types of values of the angles or the trigonometric ratios. So I think you have understood what is given in these two questions. Here are another two questions that is based on the 6 trigonometric ratios, that is the inverse trigonometric ratios. Same thing, you just practice these questions, you will get the concept regarding this. In the next class, we will learn about the trigonometric ratios of some specific angles. Thank you.